Generator excitation control systems and methods. Ever wondered what keeps a generator's power output stable? Especially during those critical moments, like during a blackout, a motor startup, or a sudden load demand? The secret lies in something called excitation. In today's audiocast, we'll take a guided look at four common excitation systems, how they work, where they excel, and what to consider when choosing between them. By the end, you'll have a clear understanding of how different excitation methods can affect the performance and reliability of your generator. What is excitation and why it matters? At its core, generator excitation is about feeding the rotor's magnetic field with a regulated direct current. This process determines how stable and reliable the generator's output voltage will be. The heart of the system is the automatic voltage regulator, or AVR. Its job is to sense voltage levels and adjust the excitation accordingly. Traditional AVRs use silicon-controlled rectifiers known as SCRs, which rely on signals from the stator. They work fine with simple linear loads but can struggle with nonlinear ones. More advanced AVRs use field effect transistors, or FETs, which provide pulse-width modulated signals that handle complex and fluctuating loads much more effectively. Shunt or self-excited systems. The first excitation method is the shunt, often called self-excited. This design powers the AVR directly from the stator. It's straightforward, cost-effective, and requires minimal components. Because of its simplicity, it's also easy to troubleshoot and maintain. However, the trade-off is that performance can decline under heavy load conditions. As the load increases, voltage may drop, which puts more demand on the AVR. If the load is highly nonlinear, like systems with motor drives or variable frequency drives, the AVR may not be able to keep up. That can lead to voltage instability or, in worst cases, failure. Shunt systems are best suited for applications where loads are steady and predictable. Excitation boost systems. The next method is the excitation boost system, or EBS. Think of this as a support system that steps in when the generator faces a demanding situation, like starting a large motor. The EBS includes an excitation boost generator and a control module mounted on the alternator. When needed, it delivers an extra surge of excitation current, helping the generator maintain voltage stability during those critical moments. The important thing to remember is that the boost is temporary. It's designed for short-term demand, not continuous operation. EBS systems are ideal when generators regularly face tough motor starts, but don't require constant supplemental excitation. Permanent magnet generators. Moving on, we have the permanent magnet generator, or PMG. This is often seen as a premium option. Instead of relying on stator power, PMGs use permanent magnets on the generator shaft to provide their own clean, isolated excitation source. The benefits are significant. With a PMG, you get stable voltage right from startup, excellent short-circuit handling, and reliable operation under widely varying loads. This makes PMG systems particularly valuable in environments with nonlinear loads or critical equipment that cannot afford voltage fluctuations. If you need consistent performance in demanding or unpredictable conditions, PMG excitation is one of the best choices. Auxiliary winding systems. Another method worth exploring is the auxiliary winding system, sometimes called AUX. In this design, extra windings are built into the stator to provide supplemental excitation voltage. These systems are useful when additional support is needed during times of high demand, such as motor startups or heavy surges. Auxiliary winding systems are durable and often used in industrial, marine, and heavy-duty applications where reliability is essential. They're a practical middle ground between simpler shunt systems and more advanced PMG setups. Choosing the right method. So, how do you decide which excitation method is right for your generator? Start with your load profile. If your loads are linear, steady, and predictable, a shunt system may be all you need. If you regularly face motor startups but not ongoing heavy demands, an excitation boost system could be the right fit. For environments with critical or non-linear loads, a PMG system offers the stability and reliability needed to handle almost anything. And if you're working in heavy-duty or marine environments, auxiliary winding systems provide durability and support where it counts. Conclusion: excitation may not be the first thing that comes to mind when you think of generator performance, but it plays a vital role in keeping systems reliable, responsive, and safe. From simple shunt systems to robust PMG setups, each method has its place depending on the application. Understanding the strengths and limitations of each option helps ensure that your power system can perform when it matters most. Thanks for joining us on this deep dive into generator excitation methods. If you'd like to learn more, visit us at generatorsource.com for additional insights, guides, and resources. And don't forget to subscribe to our audiocast for future episodes where we cover everything from maintenance tips to industry trends. Until next time, stay powered and informed.